A very good morning to all. I am Karthik, Assistant Professor, Mechanical Engineering Department, SNS College of Technology. This short lecture is about the case study on failure analysis of mill shaft roll. The first thing is that before going to the fracture analysis, we should know what is the history or past behind this fracture. The first one is that this shaft is mainly installed in the rider roller shaft, which is used in the mills. Okay. The second one is that this shaft is installed at late 1997 December, and there are some small cracks at the center of the roll, so it is replaced at March 1998. So even after replacing, we can see there is a crack at the center part, at the keyway side, while the machine is put at the slow speed. Usually the shaft is operated at 550 to 630 rpm. So here as we see in the metallurgical part, you can have four types of major fractures. First is brittle, ductile, creep and fatigue. The first two, ductile and brittle, does not happen here. It may have a chance to happen, but it is not predominantly going to reach on this side. That's because the ductile and brittle failures analysis is done already, so there is no evidence of ductile and brittle failure. The third one is creep. The creep usually occurs at high temperature, but there is no possibilities of having high temperature at this point. The fourth one is fatigue. The fatigue has a maximum possibility to occur here, which because this fatigue has the usually occurs at the high temperature. So in this regard, you can say the fatigue has the high possibility to occur. Moreover, this machine is operated at 550 to 630 rpm. Usually it's a high speed range. Other than that, you can see there are a bigger crack which is out, just can be say at 35% of the total area. Second one is that by visualization, naked visualization or eye-to-eye visualization, you can see the beach marks of fatigue is usually absorbed in that fracture area. So this is the fracture area. So when we take cross section, you can see some major cracks and other cracks, which here you can see some beach marks are around. So this beach marks implies that this is due to the fatigue. The other one is that you can see some there is some weld overlay flaws at the surface of the shaft. Okay, so as we analyze the shaft which is failed, you can see it is more or less matching with the AISI 1019 standard composition. So as we can see, this is the micrograph of core microstructure, which is composed of ferrite and perlite, which is etched with 2% nitol. So this is here the first photograph shows the fracture surface, second photograph shows the inclusions that are present at the inclusions at the overlay, and the fractures at the surfaces where the crack initiations has happened. Okay, so the conclusion is that this failure is mainly due to the high cycle low stress fatigue, which is initiated at the inclusions in the weld overlay. So both the fatigue range and the inclusions both places the major role here. The first, as I mean this high cycle low stress fatigue, there are other type of fatigue which is low cycle high stress fatigue. Here, when there is an absence of other failures also, you can see the important the surface conditions are the important factor for the crack initiation. But so in this regard, you can see there are some flaws or the weld overlay. So the other one is that I think the bending of shaft is with alignment should be corrected, so this causes decohesion of weld inclusions, encouraging micro cracks to form. So this could increases the low stress concentrations and possibility of crack initiations. So the other thing is that the weld overlay over an existing rolls is possible, can be reconstructed, but some welding procedure should be done in order to have a proper welding conditions at the proper welding work, and also to avoid the cracks at the later part. So here so after the weld overlay, you should have a liquid penetration test, so that if there is any cracks at the surface level, it can be easily identified. even after welding. So the last thing is that the property of the material falls between 1019 and 117 for pH. It will resist crack initiation better than the former because due to the high endurance limit, it will resist the crack, which is because of high fatigue, high fracture toughness. So you should avoid bending of shaft, and surface should be hardened to avoid the cracks at the surface area. So surface heat treatment should be done. So to avoid the mechanical damage such as cracks and dents, so it should be avoided so that the crack initiation part possibilities will come lesser. And the last one is that some coating or painting should be done after the weld overlay, so that the corrosion will be controlled controlled very much. Thank you.